Hi, I'm Victoria Lee, and this is my presentation on ionizing radiation in the workplace. In my presentation, I'll be answering the following questions. What is ionizing radiation? Where can I be exposed to ionizing radiation? What are the health effects of exposure to ionizing radiation? How can I protect myself from overexposure? And is my job as a radiologic technician safe? There are two types of radiation. There is non-ionizing radiation and ionizing radiation. On the electromagnetic spectrum, the dividing line between ionizing and non-ionizing radiation occurs in the ultraviolet part. If you look at the spectrum on the slide, non-ionizing radiation is to the left and is considered to have lower energies. Some examples include radiofrequency radiation used in broadcast and communications applications, microwaves used in the home kitchen, infrared radiation used in heat lamps, and UV radiation from the sun and tanning beds. The biggest difference between non-ionizing radiation and ionizing radiation is the way each type acts on materials. Because non-ionizing radiation is considered low energy, it cannot remove electrons from atoms and molecules. The most remarkable quality of non-ionizing radiation is its ability to heat substances, which is why a microwave oven heats water and food. In the next slide, I'll present the qualities of ionizing radiation. Ionizing radiation is high levels of energy emitted from an atom or nucleus of molecules in the form of waves or particles. Some examples of ionizing radiation are alpha, beta, X-ray, and gamma radiation. Alpha has the lowest energy. It is the emission of clusters of 2 neutrons and 2 protons from the nucleus of an atom. Because it is low energy, it cannot even penetrate a piece of paper or even the layer of dead cells on the surface of our skin. Beta has a little more energy than alpha. It is the emission of electrons. It can penetrate through paper and skin. Gamma has the highest energy. It is the emission of energy packets known as photons. It can penetrate the human body more deeply than alpha and beta. X-ray has an intermediate level of energy. X-rays are artificially produced, so it can be adjusted to emit as high of energy as gamma radiation, so it too can penetrate the human body. Overall, because ionizing radiation is considered high energy, these types of radiation can penetrate through paper, the human body, and even concrete and metal. So, where is ionizing radiation? Naturally, there's ionizing radiation everywhere. The Earth's atmosphere is continually bombarded by cosmic radiation from the sun and other events in outer space. Although the atmosphere provides protection from most of the cosmic rays, there is still some ionizing radiation that will penetrate and become absorbed by humans. The dose of cosmic radiation varies with elevations above sea level in longitude and latitude, but generally, regions at higher altitudes receive more cosmic radiation. Another natural source of ionizing radiation is terrestrial radiation. The one environmentalists are most familiar with is radiation exposure from radon. Radon is a natural product of uranium decay. The Earth's crust naturally has large deposits of uranium, so radon is everywhere. That is why most homes are tested for radon levels to prevent overexposure. There is also trace amounts of radioactive minerals in the organic foods we eat and the water we drink. Because most of our foods are cultivated in soil, which contains radioactive minerals, we become exposed to this natural radiation when we eat. Lastly, our body contains several radioactive isotopes, so we also emit minute levels of ionizing radiation. While we are exposed to natural sources of ionizing radiation every day, there are man-made sources of ionizing radiation that are also part of our daily lives. Man-made sources of ionizing radiation are emitted from things you would never suspect. Intuitively, it's easy to believe that ionizing radiation can come from atomic weapons and nuclear power plants. But ionizing radiation can also come from common daily objects including tobacco products, old ceramics, smoke detectors, glow-in-the-dark exit signs, building materials, wristwatches, false teeth, medical imaging techniques, and LCD screens. In the last slide, it was mentioned that medical imaging was a man-made source of ionizing radiation. As a radiologic technician, it is important for you to be aware of your potential exposure to ionizing radiation while performing daily medical imaging studies for your job. The most common source of ionizing radiation in the hospital would be X-rays. X-rays are used ubiquitously. They are used in the orthopedics to image broken bones. They are used in dentist's office to visualize teeth maturation. They are also used as screening tools for breast cancer as mammograms. It is safe to say that almost everyone has had an X-ray performed, which means almost everyone has been exposed to the ionizing radiation from X-rays. Other common sources of ionizing radiation in the hospital would be CT scans, PET scans, fluoroscopy, and nuclear medicine procedures. So far, we have learned that there is exposure to ionizing radiation everywhere. You can be exposed while walking through the park, reading a book at home, and working in the hospital. We can hardly avoid ionizing radiation. So the next question we should ask is, what are the health effects of exposure to ionizing radiation? The health effects caused by ionizing radiation is due to its ability to damage DNA directly. When DNA is damaged, it can cause cellular abnormalities which can lead to organ dysfunction. The severity of health defects depends on the dose of radiation and the length of time of exposure. If someone has exposed their entire body to an extremely large dose of radiation, they are at risk of acute radiation syndrome. Acute radiation syndrome can affect the bone marrow, gastrointestinal system, cardiovascular system, nervous system, and skin. Some symptoms include skin burns, headaches and confusion, and diarrhea. There is an intermediate stage of the syndrome in which the person will suddenly feel healthy, but this stage is quickly followed by a second wave of worsening symptoms. People can recover from acute radiation syndrome after several weeks to years, but many people will die within months of exposure. Furthermore, if someone is exposed to ionizing radiation over a long period of time, they are at risk of developing cancers, and there are no specific cancers that ionizing radiation is associated with. So how much is too much exposure to ionizing radiation? The average person receives 620 millirem per year. Half of the exposure can be accounted for by natural sources, which is labeled background on the pie chart. Medical exams and imaging almost make up the other half, and less than 5% of exposure is due to consumer products, industrial sources such as nuclear power plants, and occupational sources. People are at risk of acute radiation syndrome if they receive more than 70,000 millirem in a short period. That's more than 1,000 times more than the average amount. Meanwhile, there are no studies to suggest a specific amount that will cause cancer. However, current science suggests that there is some cancer risk from any exposure to radiation. It is not possible to tell whether a particular cancer was caused by a very low dose of radiation or by something else. Now that you know the risk of ionizing radiation, you should be asking yourself, how do I protect myself? First, you should avoid entering procedure rooms using radiation if your assistance is not needed. Second, you should always wear appropriate personal protective equipment, or PPE. This includes, but is not limited to, a lead apron, thyroid shield, and radioprotective goggles. Third, if you must be present during the use of ionizing radiation, try to stand as far away as possible from the machine emitting radiation. Last, use the lowest amount of radiation as possible with every procedure. Most importantly, if you are pregnant, exposure to ion radiation should be avoided at all costs, as radiation can harm the fetus. Although it would be a rare event in a hospital, in the event of a radiation exposure emergency, you should take the following steps. Initially, you should perform radiation control measures, such as minimizing time of exposure, maximizing distance from source, and shielding your body from the radiation. Next, you should decontaminate your body as soon as possible. Start by removing clothing, which will reduce contamination by 90%. The decontamination process involves performing 2 cycles of washing the body. Tepid decontamination water should be used. Cold water should be avoided because it will close skin pores and trap radioactive contamination. Hot water should be avoided because it enhances absorption of radiation material. Mild neutral pH soap should be used to emulsify and dissolve the contamination. After decontamination, some radioactivity may be trapped in the outermost layer of skin and will remain until normal sloughing of skin, which takes 12 to 15 days. After learning about the dangers of ionizing radiation and the risk of exposure as a radiologic technician, the last question we should be asking is if your job is safe. There are many research studies measuring the dose of ionizing radiation that medical workers are exposed to. According to one study performed at a university hospital in Saudi Arabia, the average measured annual dose of ionizing radiation that workers are exposed to was significantly less than the international recommended dose limit of 20,000 millirem. The study accounts the low dose of exposure to the workers wearing appropriate protective equipment such as lead aprons and thyroid shields. On the other hand, the NIH has been conducting studies about mortality rates and disease incidence among radiologic technicians and have found evidence suggesting increased incidence of cancer. The study suggested that occupational exposure had varied levels of risk based on what procedures the radiologic technicians performed. For example, there was no link to increased risk of cancer if the technicians were regularly performing nuclear medicine procedures. On the other hand, there was some increased risk of cancer if the technicians regularly performed fluoroscopy-guided procedures. However, there are many factors rather than just occupational exposure that the studies explored. For example, the studies proposed that an increased incidence of cancer could be measured because of earlier detection among healthcare workers such as radiologic technicians. The studies also suggest that modifiable risks such as obesity play a role in increased incidence of cancer among radiologic technicians. Overall, being a radiologic technician should be a safe job as long as proper safety precautions are followed. In summary, this presentation shed light on ionizing radiation and its natural and man-made sources, which include consumer products and medical exams. I also highlighted the adverse health effects of radiation exposure and important safety precautions to stay safe. If you want to learn more about occupational exposure and protection, visit OSHA's website for safety and health regarding ionizing radiation exposure. If you want to learn more about sources of daily exposure and how much radiation you might be exposed to, visit the EPA's website for radiation sources and doses. If you want to learn about research projects studying the risk of being a radiologic technician, visit the NIH U.S. Radiologic Technologist Studies website. This is my works cited. Thank you for your attention.